Okay guys, so we're going to talk about some applications of fractions in real world problems that you might care about or see in the future. So our first one is you are trying to learn about Florida waterways. You read that half of all American waterways are polluted. You also read that about 2/10 of Florida's total area is covered in water. What fraction of Florida's total area would be water that's not polluted? So I want you to pause the video and try these problems before you see me walk through and do the solution. I think students tend to learn much more that way. So go ahead and pause the video now and try this first one. Okay, so we're given that half of all American waterways are polluted, and we're also given that 2/10 of Florida's total area is covered in water. So what we want to do is we want to take that 2/10 of the total area that's covered in water and take half of it, because we can kind of extrapolate that maybe if half of all U.S. American waterways are polluted, then maybe that's also roughly true for Florida as well. So we're going to take 1/2 of this 2/10, which to do that, we're just going to take 2/10 and divide it by 2, which is equivalent to taking 2/10 and multiplying it by 1/2. Whoops. So we're going to multiply these two fractions, and we end up getting 2/20, which is the same as 1/10. And so we can say that 1/10 of Florida's waterways not of Florida's waterways, hold on, of Florida's total area is non-polluted water. Okay, now the second problem. We have that you are working as a nurse and have been giving a patient 2 2/3 cc's of Tylenol every 4 hours. Their fever's not getting better. The head nurse tells you to increase the recommended dose by 1/4 to see if that helps. How much Tylenol should you be giving the patient now? Again, pause the video, try to do this problem, and then resume the video when you're ready to see the solution. Okay, so our original dose was 2 2/3 cc's of Tylenol. So we're going to write 2 2/3 cc's of Tylenol, which is equivalent to, usually it's easier, at least in my opinion, easier to work with improper fractions when we're doing different operations than it is to work with mixed numbers. So I'm going to convert this to an improper fraction. 2 times 3 gives me 6. I add the 2 from the numerator of the 2/3, and that gives me 8/3. So we've been giving 8/3 cc's of Tylenol every 4 hours. And then we want to increase this by 1/4. So what we need to find is 1/4 of the original. And then we'll go ahead and add that in. So we'll take the original amount and then add in 1/4 of it. So we're first going to find 1/4 of that original. Well, if I want to find 1/4 of 8/3, that means that I'm finding 1/4 of 8/3, which is like taking 1/4 times 8/3. Keep in mind, this is also equivalent to taking 8/3 and dividing it by 4, because we're just multiplying by the reciprocal, which is 1/4. And then that gives us 8/12, which is the same as 2/3. So this is the amount that we need to add on to our original amount. So it asks, how much Tylenol should you be giving the patient now? You should give, whoops, that's not spelled correctly. You should give our original amount, 8/3, plus the 1/4 that we're adding on, which 1/4 of the original amount is 2/3. So we get 10/3. And if you're wanting to write this as a mixed number again, because often when, let's say you're giving it out of a syringe, usually those are written in mixed numbers. So 3 goes into 10 3 times, and then we have an extra 1/3 left over. So we're giving 3 and 1/3 cc's of Tylenol the next time around. All right, now we have Caden is tiling a wall in a bathroom, and he wants to use the following pattern, which is going to be repeated throughout the wall. He measures that the wall is 8 feet by 5 feet. I'm going to write some of this down. So we have the wall is going to be 8 by 5 feet. He goes to the store and wants to purchase the exact number of tiles that he will need. The tiles he is purchasing are square tiles and will have a side length of 6 inches. So that means each of these tiles is going to be 6 inches by 6 inches, which, since we're talking about the wall in feet and the tiles in inches, we might as well convert one to the other to be consistent. I'm going to go ahead and convert the 6 inches to 1/2 a foot. So we have 1/2 foot by 1/2 foot tiles, and then we have an 8 by 5 foot wall, which I will list the units here. 8 foot by 5 foot. Whoops. Okay, so we want to figure out how many tiles of each color he should buy. Go ahead and pause the video, try to do this problem, and then I'll show you the solution. Okay, so the first thing that I would do is figure out how many tiles does he need? Like, how many tiles in total? And then I'll worry about, how am I divvying that up based on color. To figure out how many tiles he needs, I need to figure out how many tiles do I need to cover the entire wall, right? Which means I need to make sure that the area of the tiles that I'm buying is equal to the area of the wall. So it might be beneficial to figure out the area of the wall, which is exactly 8 by 5 feet. And the area is 8 times 5 feet squared. So we have 40 square feet. So we need enough tiles to cover 40 square feet. So what we can do is find the area of each tile and then divide 40 by that number, and that should tell us how many tiles will cover 40 square feet. So I have the tiles are 1/2 foot by 1/2 foot. And so the area of my tiles is 1/4 square feet. And so the number of tiles needed is going to be equal to 40 divided by 1/4 square feet. And this is the same as 40 times 4. So 160. So we need to buy 160 tiles in total. Well, that's only part of the problem. So we figured out how many tiles we need to cover the entire wall, which is a problem with fractions in its own right. But now we know the pattern that he wants, and we need to figure out how many pink tiles should we buy, how many blue tiles, how many white tiles. And so to do that, we can look at the pattern and see what fraction of the tiles on the pattern are blue, what fraction of the tiles are pink, and what fraction of the tiles are white, and then use that to determine how many of the 160 we should buy. So we can write according to the pattern. We have 2 now if you count the tiles in that part of the pattern, there's 16 tiles there. So we have 2 out of 16, or 1/8 are pink. We have that 6/16 or 3/8 are going to be blue. And then 4/8 are white. Okay, so 1/8 of the tiles that we buy should be pink. 3/8 of the tiles we buy should be blue, and 4/8, which is the same as 1/2, should be white. So to figure out the number of pink tiles we need, we'll just take 1/8 of 160, so 1/8 times 160, which gives us 20. To figure out how many should be blue, we'll take 3/8 times 160, which gives us 60. And then we can take 1/2 of 160, and that's gonna, 160, and that would be 80. And so now we know the number of tiles that we need to buy in each color. So we need 20 pink, 60 blue, and 80 white. Now, of course, if you're actually tiling a wall, it might be a good idea to buy maybe like 2 or 3 extra of each tile in case you break some when you're putting them up. But here you know the number of tiles that will be sticking onto the wall at the end of the project are 20 pink, 60 blue, and 80 white.